So as you can see here, I have my pre-lab op amp set up. So at the lower resistances of the potentiometer, the LED is on at full intensity, and at the higher resistances, it's all but turned off. This makes sense for an op amp because it amplifies current at a certain point and shuts it off below that. So that makes sense. For exercise 1, the voltage out ends up being V input times R1 over R2 plus R1. That's because V in is V positive is equal to V negative, and this here is basically just a voltage divider since no current goes in here. So for exercise 2 here, I have the Unity op amp. As you can see here, the input voltage, it all matches up to 5 volts, except down to around 2 volts. This is because this is not an ideal op amp, and there is basically a minimum voltage that has to be applied for it to actually work. As you can see here, that voltage for this op amp is about 2 volts. So here I have my inverting op amp circuit. As you can see here, it's wired up with the 1 kilo ohm and 10 kilo ohm resistors. When my V out plateaus, the V in and V minus continue to decrease. When my V in and V minus plateau, the V out starts to decrease all the way to about 2 volts. As you can see, plateaus around 4.3 or so volts, and the V in plateaus at 5 as expected for full range. V minus is just slightly below that. V out's lower plateau is just under 2 volts, which is just the bottom range of this amplifier, as we found in the previous example. V out does cap somewhat early, around 4.3 volts. However, this was just expected from a non-ideal op amp, since this is a real op amp. Here's my derived output of the circuit. As you can see here, for the integrating circuit, when the V in is around 5, the output hovers around that lower limit of the op amp. As V in lowers to about 2.5 volts, then V out starts quickly climbing. As you can see, there's a time response to the inverting V's response. This is due to the capacitor in the circuit. You can see it has that time response, that smooth curve, due to that capacitor. When you get lower, the output goes higher, just like my equation would suggest. And when you go higher, output gets lower. And just noting that time response there. There is a hesitation at 2.5 volts with V minus that I don't, or V inverted, that I don't quite know. I'm gonna assume that this is due to some sort of ideal characteristic breaking down in a real op amp.